Hello and welcome to Problem Design Solution. My name is Mitchell Pearson and I will be walking you through this video. In this video, what I want to do is show you a problem that a client gave me and show you ultimately how we design that problem and the solution for that particular problem. So this is the problem that we had. We have a slicer across the top here, and of course a slicer is nothing more than a visual filter. And what the end user wanted, or what the client wanted, is they wanted to be able to not have a slicer that was an exact match, but a slicer that was more of a search filter, or would give them a search criteria. So you can kind of see here that if the end user wanted to, for example, return all the rows where the row was equal to IT department, they would have to select this item from the slicer, this item from the slicer, and this item from the slicer. This is, of course, a very small subset of the data. In his situation, he had multiple combinations of these different departments and a lot of different departments. And it was unreasonable to come in here and have to select multiple items in a slicer to find all of the different versions for the IT department and where they had those different correlations in the data. So what he wanted instead was to have a text filter where he would have just the value of IT, and whenever he searched IT, it would bring back every single record from that table where IT was contained within that record. The problem with this slicer here is that this slicer only works with an exact match. All right, so it only works with an exact match, and that's okay 99% of the time. That's what we're all used to, every one of us that's used to working with slicers. What the client needed, once again, just to reiterate here, is they needed a slicer that would allow them to search through text. All right, so what we're going to do is we're going to go ahead and flip over to Power BI Desktop, and I'm going to walk you through an example here of how we can search the text, kind of rolling out our own example, what the design of that solution is going to look like. All right, so here is our table, the same table that you saw in PowerPoint. And what I want to do here is go ahead and create the original slicer and what that looks like. So I'm going to create a new slicer in this report, bring in the affected departments. We can go ahead and make this a little bit larger real quick. So we can go down to items here. Let's make this a little bit larger. And then just so it fits on the report, I'm going to make this horizontal. All right. So this is kind of that original slicer that you saw in the PowerPoint. Once again, it works exactly like we would expect it to work, which is when you come in here and you click on, let me go ahead and change the background color. When you click on one of these items, for example, audit, IT, and tax, it filters it down only to show audit, IT, and tax. If I click on IT over here, what I would want it to do in this scenario is I want it to go ahead and bring back this record, this record, this record, and this record. But when I select it, it only brings back those two. It only brings back the exact matches. So if I want to bring back all four records for IT, I have to select every single item in my slicer that had IT in it. And once again, in this small example, that's not a problem. But as the combination of departments grows and as the number of department grows, that might get to a point where it's not really workable. So that's why we wanted to come up with a better solution here. So what I want to do instead of having this slicer is I want to have a different slicer. And the different slicer is ultimately going to be a unique combination or a unique record in that slicer for each distinct value that I might find in this row. So tax, IT, I'd have a row for finance, we'd have a row for audit, and then HR. All right, so what I would typically do is I'd have a different table in my database or an Excel file to kind of drive this data. But since this is a demo, I'm just going to create this data very quickly here by going up to the top and clicking on Enter Data. All right, and that's going to give me a nice little table here that we can create. Now I'm going to call this column here, I'm just going to call the column Departments. And then inside of the record, I'm going to add all of the different distinct values that I might find inside of those different rows. So I'll have IT, I'll have HR, we'll have finance, we'll have our audit department, and then we'll have tax. And then the last thing we need to do here is go ahead and name this table. So since this table is only going to be used essentially as a slicer, I'm going to go ahead and name that as a slicer and then load that into my data model. All right, so now we have this table in our data model. Anytime you load data in your data model, you need to go and check the relationships. And what I'm going to do is not create a relationship between these two tables. So I'm going to use the old kind of disconnected slicer method here. And I'm not going to create a relationship, which means if I select something in this table, it's automatically going to filter this table based on the relationship. Instead, we're going to create a DAX calculation that allows us to do a search operation here in this example. So we're going to go ahead and leave these two tables unrelated for this example here. All right, so now what I want to do is if I come over here, let's go ahead and create another slicer from this departments table. So I'm going to drag that column in. I'm going to turn it into a slicer. And let's go ahead and make the values a little bit larger here for the item so we can read it. And now what we want to do is now I have a distinct list of the different values from this row. And if I click on IT, I want IT to filter down these 4 rows. And if I click on HR, I want HR to filter down just this 1 row. If I click on tax, you'll see tax exists in this 5th row here as well as in this first row. Unfortunately, we know that these 2 tables are currently unrelated. We did not build a relationship between them. So we're going to create a calculated measure that's going to look for these different values in this table. And if the value is selected here, it's going to return the value from this table. Okay, so now that we've seen what the problem is, let's kind of talk about what the design is going to look like here. As I showed you in the video, you saw that we are going to create a disconnected table that has a distinct list of the values from my departments row, right? And then the next thing that we want to do is create a calculated measure that uses the search function. And the search function is where we're going to get that like functionality. Something similar to what you might see in a different programming language like T-SQL, for example, where you can say, bring back all the rows where it's like IT, where it's like FIN. Even if the row is not an exact match, it gives you that like functionality. So this is what it's going to look like. We're going to create this slicer table. We have our departments, IT, HR, Finance, Audit, and Tax. And it's simply a distinct list of values. We've already created this table. And remember that we did not create a relationship there. And then what we're going to do is use a calculated measure. And we're going to use the search function. And the search function returns the starting position of the character at which a specific character or text string is found. So for example, if I was searching through my last name of Pearson, and I was looking for maybe ER or EAR, then it would return the starting position of 2 because EAR starts at the second character of my last name, right? So it returns the value of 2. That's important because the way that we're going to use this is inside of an if statement that says, if the value is greater than 0, then we know that it was found somewhere in the text string. If the value is not greater than 0, meaning it equals 0, then we know that the value was not found. All right, so we can use search for this. Keep in mind that search is not case sensitive. In this example, it might be more applicable to use the find function because the find function does the exact same thing that the search function does, but it is case sensitive. So if you have a situation where IT, for example, could show up in just basic IT where it's capitalized, but it could also show up in audit where it's lowercase, then you might be better off using the find function rather than the search function. All right. So what we want to do now is let's jump back into Power BI Desktop, and I'm going to show you exactly how we build out this DAX calculation so that we can see how all of this works together. Okay, so now we're going to go ahead and create a calculated measure real quick. I'm going to go ahead and create this calculated measure on my department goals table. So I'll come up here to the top, I'm going to click on New Measure, and then I'm going to call this new measure is filtered. So let's go ahead and name that is filtered. And what it's going to do is I am going to kind of look through my departments table here. So over here we have this slicer with these different departments. It's 5 different departments that exist: IT, Finance, HR, Audit, and Tax. This table is going to be filtered down based on this slicer here. So whatever I select in this table, or this slicer, is going to filter down this table. So to give you an example of that, if I were to bring in, let's go ahead and create a new visual real quick. Let me move this down. I'm going to create a new visual that's a table visual. I'm going to bring in my departments from that table. Notice that that table and that column is only showing the tax department. The reason for that is because this slicer is directly filtering down that table. The calculated measure that we're going to create is going to be looking at this table and looking to see what values exist in the departments table. Right now, it's only going to see tax, so therefore it's only going to search this table here from our original table. It's only going to search it for tax because this filter is directly filtering down that table, which is a table we're going to be iterating over in this calculated measure. All right, so let's jump back in and take a look at this DAX. So the first thing I want to do here is we're going to use a logical function. The logical function is going to be if, right? It's going to be if then else is our criteria. I do need to use the SUMX function since I am going to iterate over that slicer table that we created. And then the expression that I want to use on every row of that table is going to be using that search function. So I'm going to say search. The text that we want to look for is coming from our slicer department. So I'm going to bring in slicer departments. There we go. So it's going to go to the first row, it's going to bring that back, and then it's going to evaluate this expression. So it's going to use slicer departments. And then from my department goals table, we're going to bring in the affected departments. I am going to search each row. So I'm going to take from my slicer departments table, I'm going to take, tax, which is what exists there. So I'm going to take tax, and then I'm going to go down, I'm going to look at the first row here. I'm going to say, does tax, or bring back the starting position of tax in that table. If it exists, it's going to return the starting position, which in this table would be, or this row would be 1. In this row, it would be 0, and this, or non-existent at all. And this row would be non-existent or 0. And this row would be non-existent or 0. And then on this row down here, it would be somewhere around 11 or 12, right? So in the first record and the last record, it's going to return a value greater than 0. In these 3 records, it returns a value that's equal to 0 or not existent, maybe a null value. And the reason for that is because it has not been selected here. So that's what it's doing. It's going to take the value from my departments, from my slicer table, which is that new table that we created that has no relationship to the original table here. And it's going to search that original table for that text. All right, and then the more important thing here is we can give it a start position if we want. We don't want to give it a start position, so we'll always just start from the very beginning of that text. And then we have to give it a not found value. If we don't give it a not found value, the search function will, of course, return with an error. Now, I expect that most people watching this video is familiar with the search function, so I won't belabor that for too long there. So now we're going to close down the SUMX and the search. Once that's done, what we want to do is say, look, if it meets a criteria, so the criteria that we're actually looking for here is 0. So let's do this. If it's greater than 0, if it meets that criteria, then it's true. What do we want to return if it is true? So remember that row 1 here and row 5 were greater than 0. This one returned a value of 1 because tax was found on the starting position of tax was in 1. This one was closer to maybe 12 because if we count this out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The tax, the string of tax that we're looking for, starts at the 12th character there. So if it's greater than 0, meaning it does exist, then we want to return a value of true. And I'll show you exactly where we're going to use this in just a minute. If it doesn't exist, then we want to return a value of false. All right, and then we can kind of close that out. So that's all this expression is doing. I'm going to iterate over that slicer table, and then for each row in that table, we're going to perform this operation or this expression. We're going to check to see if in the department goals table, if the value is greater than 0, if it is, return true. If not, return false. All right, so we can hit enter now. Then let's zoom out, collapse that. And now we still haven't related these two together. All right, I still haven't done anything here as far as relating these two tables together, but I will show you what this is now going to look like. So I'm going to take that new isFiltered calculated measure that we created. I'm going to drag and drop it into my table over here. And this is going to give us an indication of what's going on. So notice that when I select tax, you can see that the first row and the first row both now reflect true. Exactly what we expected to happen there. All right. The cool thing about this is because we're using that iterator function, we're iterating over the table, we can use multiple search criteria. So I can come in here and search HR, and now you'll see any row that exists where HR exists in the row or tax exists in the row, the corresponding isFiltered over there to the right is going to say that true, it is filtered. All right, it is filtered. Remember the way this works again is we are using our calculated measure on this table up here. This table is directly filtered by our slicer, and that's how all of this works, even though we don't have a relationship. All right, and the cool thing about this is you don't have to be intimately involved or completely understand every single thing I'm doing. This is a process that's very easy for you to duplicate in your environment if you're looking for some type of search slicer criteria like I have here. All right, now the next thing we need to do is we now need to tie this calculated measure of isFiltered. We need to tie it to this table, to this visual that we're using here. And the way that we do that is I'm going to go and click on the visual. And then in the visual, let me go ahead and get rid of the isFiltered from the table. isFiltered doesn't need to be in the table anymore. But what I want to do is slide down a little bit. And in my visual level filters, I am going to, if it didn't exist already, which it exists because I had it in the table, if it didn't exist, I would take my isFiltered calculated measure and drag that into the visual level filters here. All right, so I'm going to drag it and add it to my visual level filters. Then I'll go ahead and expand it. And then what I want to do is I want to come in here and say, if it is, all right, if it is true, so if the value of that row isFiltered is true, then we want to display it and show it in the table. All right, so I'm going to go down here and apply filter, then we'll zoom back out. And now you will see that the only records that are showing in this table now are the ones that are HR or tax. All right, let's go ahead and remove those. If I remove those filters, everything shows up because everything's selected. But if I click on IT now, Notice that when I click IT, it only shows the 4 records from affected departments where IT exists, but it does show all 4. That is in direct contrast to this up here, which was our original filter, which if I were to click IT up here, it only showed the exact matches, right? But now when I click IT, it's doing a search, and it's able to return the search criteria rather than the exact match in that original filter. So we don't need the original filter anymore. We don't need the table here. That was just for demo purposes and kind of visualizing exactly what was going on and how this was working. But now you'll see we can do multi-select, we can do all kind of things. So let's say I wanted to do audit. I can click audit, and then I can click on finance. So even though audit and finance are not exact matches, they're showing up. We could do HR. Well, HR and finance share the same one, and then we could do tax, right? So that is how we can essentially go through the design and the solution of solving this problem of looking for a slicer that's going to do a search and not an exact match. All right, so the final solution is we now have a new slicer that allows filtering using a text search rather than an exact match. So just to review real quick, we have our problem, design, and solution. We showed the problem, which was using a slicer performing an exact match. And then we walked through creating a disconnected table and a calculated measure that allows us to overcome the problem by doing a text search. And then finally, the solution there was to take that new calculated measure and add it to the filter section of the visualization and say, if it equals true, we know it exists, so we want to make sure that those records are returned. The ones that do not return true, they're being filtered out, so we do not bring back those records. All right, we thank you for watching, and if you're interested in some formal training, feel free to use the promo code on the screen there, and you can go to pragmaticworks.com and sign up for our on-demand training. Thanks again, and enjoy.